In this video, we will be describing functions. Here's an example. A high school is having a sale to raise money from donated cakes. The revenue R depends on the number of cakes sold N. Here's a revenue table. Why is this relation also a function? Identify the independent and dependent variables, and write the domain and range. This is a function because for each number in the first column, there's one and only one number in the second column. The numbers in the first column, the N column, the number sold column, are unique. The input is the independent variable, which is the number sold. The output is the dependent variable, which is the revenue R. The first column is the domain. A set of 0, 1, 2, 3, ... known as the ellipsis. The ... means the domain continues. The domain is all natural numbers. The second column is the range. 0, 14, 28, 42, and so on. This is the product of each natural number and 14. The equation is R equals 14N. A table of values usually represents a sample of the ordered pairs. So remember this as we go forward. To summarize, when describing a function, we may need to first verify the relation is a function. Then we identify the independent and dependent variables and choose variable names in context. For example, R for revenue. Next, we should list domain and range and try to write a proper equation. Sometimes all we can produce is a table of values. Let's practice building a table of values. Use the input-output machine below to generate a list of ordered pairs X, Y. The input-output machine first involves quadrupling and then adding 1. So let's run through 1. 1 gets quadrupled, gives us 4, and then we add 1 to the 4 to get 5. Our ordered pair is 1, 5. Let's try 2. 2 gets run through the first part of the machine, gets quadrupled to 8. Then we run 8 through, add 1, and we get 9. Our ordered pair is 2, 9. Let's try 3. 3 gets run through the first part of the machine, gets quadrupled to get 12. We run 12 through the second part of the machine, add 1 to get 13. Our ordered pair is 3 and 13. So let's try to generalize. Let's try to write an equation. Let's run through an X. We run an X to the first part of the machine, it gets quadrupled. We get 4X. And then we add 1 to the 4X to get 4X plus 1. The equation is therefore Y equals 4X plus 1. An equation usually represents all of the ordered pairs for a relation within context. Is Y equals 4X plus 1 a function? Look at the first column. These numbers are all unique. There is no repetition. This is a function since for every number in the first column, there can only be one number in the second column. Let's use the equation developed from the input-output function machine below to generate the ordered pair when X equals 19. Recall the equation is Y equals 4X plus 1. What we need to find Y when X equals 19. Replacing the X with 19 and following the order of operations, we do 4 times 19 first and then add 1. We get 76 plus 1. Y is 77. This leads to the ordered pair 1977. Is there an alternate way to write this equation that automatically indicates it is a function? What is this alternate way? And use the alternate way to generate the ordered pair when X equals 19. The equation is Y equals 4X plus 1. Since Y depends on X and is a function, we can now use F bracket X closure bracket instead of Y. This means that Y is a function of X, and we can now use F bracket X closure bracket equals 4X plus 1. but that's a mouthful. So we say f of x is equal to, rather than f bracket x close your bracket. Our equation is now f of x equals 4x plus 1. Let's find the f of 19, which is the y number when x equals 19. F of 19 is 4 times 19 plus 1. We do the order of operations first to get 76 plus 1, so the f of 19 equals 77. Y, which is the f of 19, is 77. The f of x notation is called function notation and is just another way of representing the y value. Here's more practice. You may wish to hit pause here and try this one all on your own. We revisit example 1 here. A high school is having a sale to raise money from donated cakes. The revenue R depends on the number of cakes sold N, and the revenue table is as below. Recall that the equation developed was R equals 14N. Our task here is to write this equation using function notation and use it to determine the revenue when 16 cakes are sold. First, the independent variable was the number sold, and the dependent variable was the revenue R. Recall number sold was N. Using function notation, the equation is now R of N equals 14N. And this makes sense because revenue R is a function of the number sold N. Revenue depends on number sold N. We want to find the R of 16, which is the revenue when 16 cakes are sold. R of 16 is 14 times 16, simply replacing the N with 16. 14 times 16 is 224, so the R of 16 is 224, meaning the revenue is $224 when selling 16 cakes. Please proceed to the next video in this lesson, and thank you for viewing.